So that is the reason for using sin theta here instead of cos theta. When do we use cos theta? Dot product. For dot product, we use cos theta. Cross product, we have to use sin theta. I think that doubt is clear. Okay. Next time. So. Find magnitude of vector A dot vector B if magnitude of vector A is equal to 5, magnitude of vector B is equal to 13, and magnitude of vector A cross vector B is equal to 25. Find magnitude of vector A dot vector B if magnitude of vector A is equal to 5, magnitude of vector B is equal to 13, and the magnitude of vector A cross vector B is equal to 25. Is equal to 25. Okay. Here we have to use cross product first of all. Magnitude of cross product means magnitude of vector A into magnitude of vector B into sin theta. N cap is not required. What is the n cap? Modulus of n cap is 1, right? So that one is not there in the properties you have studied. So we use this modulus, magnitude of vector A cross vector B is equal to 25. And what is modulus of vector A cross vector B? Magnitude of vector A into magnitude of vector B into sin theta. N cap is not required when we take the magnitude. This is equal to 25. Equal to 25. This is equal to 25. Now we substitute 5 into 13 into sin theta is equal to 25. So what is sin theta from here? 25 by 5 into 13. 5 and 25 will go. 5. So what do you get? Yes. 5 by 13. This is sin theta. Sin theta is 5 by 13. Now we have to find out dot product. For dot product, what is required? Cos theta is required. From sin theta, how can we find cos theta? There are two methods. One method is identity. Cos square theta is equal to 1 minus sin square theta. Second method is triangle. Sin theta is opposite side by hypotenuse. We find adjacent side and find cos theta. So I will use identity method. What is identity method? Cos square theta is equal to 1 minus sin square theta. So that comes like this, 1 minus 5 by 13 the whole square. What is 1 minus 5 by 13 the whole square? 1 minus 25 by 169. It is equal to 169 minus 25. What is that? 144 by 169. Therefore, cos theta is equal to, yes, what is cos theta? 12 by 13. Cos theta is positive is enough here because in dot product and cross product, the acute angle we take. So this is 12 by 13. And now we find magnitude of vector A cross vector B. Vector A dot vector B. It is modulus of vector A into modulus of vector B into cos theta. What is a modulus of vector A? Yes, 5. 5 into 13 into 12 by 13. 5 into 13 into 12 by 13. We cut this 13 and 13. Now 5 into 12. 5 into 12 is 60. It is 60. So this is equal to 60. Is it clear? So this is the calculation, complete calculation of this. Okay. Any doubt? This is clear. Next sum. If vector A and vector B, if vector A and vector B, if vector A and vector B are two unit vectors, inclined at an angle theta, inclined at an angle theta, then prove that cos theta by 2 is equal to half of magnitude of vector A plus vector B. Prove that cos theta by 2 is equal to half of magnitude of vector A plus vector B. Please try this question. If vector A and vector B are two unit vectors means their magnitudes are 1. So we start with that one. So this is also an important 3-marker type question. Since vector A and vector B are unit vectors, magnitude of vector A is equal to magnitude of vector B is equal to how much? 1. Modulus of vector A is equal to modulus of vector B is equal to 1. Okay, so now we should find out magnitude of vector A plus vector B. Normally, to find out modulus, magnitude, what do you have to do? A property from dot product. What is that property? How do you find the magnitude modulus using a property of dot product? You're not practicing daily? Using a property of how many sums we have done? Breaking modulus. What to do to break the modulus? Online also, please answer, children. To break the modulus, what we have to do? Squaring it. To break the modulus, we studied this rule. Magnitude of vector A square, modulus of vector A square is, how many sums we have done? What is that? Vector A dot, vector A vector dot, A vector, right? So to break the modulus, every question of magnitude, modulus based division, to break it, what we have to do? Square it. So here also we do the same. Modulus of vector A plus vector B square. We will do the squaring of that modulus part. Modulus square is, according to this property, that vector dot the same vector itself, which means vector A plus vector B dot vector A plus vector B. Vector A plus vector B dot vector A plus vector B, which is equal to, we have to multiply as binomial multiplication, we get 4 terms. What are the 4 terms? Vector A dot vector A plus vector A dot vector B plus vector B dot vector A plus vector B dot vector B. Now, vector A dot vector A is a magnitude of vector A square plus 2 times vector A dot vector B plus magnitude of vector B square. Now, what is a magnitude of vector A? 1. 1 square plus vector A dot vector B is magnitude of vector A into magnitude of vector B into cos theta plus modulus of vector B square is also 1 square. Now we can add 1 square plus 1 square. The first term and last term, when you add, what do you get? 2. So it is 2 plus 2 into 1 into 1 into cos theta, because modulus of vector A and modulus of vector B are equal to 1. So what is this? 2 plus 2 cos theta. 2 plus 2 cos theta. All of you understood these steps? Any doubt? We can take a common factor outside, and what's that common factor? 2 is the common factor. We take 2 outside. So when you take 2 outside, what do you get, children? 1 plus cos theta. 1 plus cos theta, 1 plus cos 2a you have studied using that. What is 1 plus cos theta? 1 plus cos 2a is 2 cos
2
square
cos
a.
square theta by 2.
Yes, it's 2 cos square theta by 2. Correct answer. 2 cos square theta by 2. Clear? Trigonometry. Trigonometric result, 2 cos square theta by 2. Now 2 times 2, it is equal to 4 cos square theta by 2. 4 cos square theta by 2. 4 cos square theta by 2. So we got modulus of vector A plus vector B square is equal to 4 cos square theta by 2. 4 cos square theta by 2. Hope you all understood this step. 4 cos square theta by 2. Yes. Now we have to do the square root on both sides. We are going to take the square root on both sides. Square root on both sides. So when you take the square root, you get that answer. So this is the last step, taking square roots on both sides, which means now we got like this. 2 cos square theta by 2 is equal to magnitude of vector A plus vector B square. Taking square roots we get, 4 cos square, last step, 4 cos square. Taking square root, what do you get? 2 cos theta by 2 is equal to magnitude of vector A plus vector B, or cos theta by 2. What is cos theta by 2 from here? Half of magnitude of vector A plus vector B. Half of magnitude of vector A plus vector B. This is the complete answer to this question. Cos theta by 2 is equal to half of magnitude of vector A plus vector B. Is it clear? Yes. Nathaniel, it is magnitude. Magnitude is positive. Magnitude is always positive. Okay, magnitude means length of the vector. That is called the magnitude. It is positive. Next, a similar question we have, that is sin theta by 2 is half of magnitude of vector A minus vector B. Sin theta by 2. When you do that question by squaring, you will get towards the end like this. 1 minus cos theta. What is 1 minus cos theta? 2 sin square theta by 2. Then you will get the answer as sin theta by 2. Okay, so please do that also right now. If vector A and vector B are, if vector A and vector B are if vector A and vector B are 2 unit vectors, inclined at an angle theta, then prove that cos theta by 2 is equal to sorry, sine theta by 2 is equal to, then prove that sine theta by 2 is equal to half of magnitude of, what will be that? Vector A minus vector B. Half of magnitude of vector A minus vector B. Yes. Can you try this question the same way? I'll take the attendance by that time. All of you, please try this one. So here also you start with the same thing. Since vector A and vector B are unit vectors, since vector A and vector B are unit vectors, please write the magnitude. Attendance Aaron Matthews. Arhan.
Present, sir.
Aaron. Aaron Mariam. Christine.
Present, sir.
Jamit. Johan.
Sir.
Joshua.
Present, sir.
Karen. Lisan. Muhammad Ibad. Mustafa. Nandana, Nandita, Nathaniel,
Present, sir.
Koisar,
Present, sir.
Indra, Shivanation,
Present, sir.
Sneha, and Umesh.
Present, sir.
Absent is Aaron, Mustafa, Sneha. Okay, so let's continue. Did you complete? How many of you got the answer? Yes. So here also you did the same way. Since vector A online also some students have completed. Nathaniel finished the answer. Yes, listen, it is noted. Fine. So here also you have done the squaring, right? Here also magnitude of vector A and magnitude of vector B are 1 since they are unit vectors. So magnitude of vector A minus vector B square is equal to, what is that? Vector A minus vector B dot vector A minus vector B, and we do like this: vector A dot vector B minus vector A dot vector B minus vector B dot vector A plus vector B dot vector B. So that is equal to magnitude of vector A square minus 2 times vector A dot vector B plus magnitude of vector B square. It is equal to 1 square minus 2 times modulus of vector A into modulus of vector B into cos theta plus 1 square. That is 2 times 2 into 1 cos theta. All of you got these steps, right? Which means 2 into 1 minus cos theta. What is 1 minus cos theta? 2 sin square theta by 2. 1 minus cos theta is 2 sin square theta by 2. So when you take the square root, so this is 4 sin square theta by 2, and when you take the square root, what do you get? 2 sin theta by 2 is equal to magnitude of vector A minus vector B, or sin theta by 2 is equal to half of magnitude of vector A minus vector B. So this is the right answer to this question. Sin theta by 2 is half of magnitude of vector A minus vector B. Please do this one. Sin theta by 2 is half of magnitude of vector A minus vector B. Next term. Next answer. Find a vector. Find a vector find a vector of magnitude 9 units. Of magnitude 9 units, which is perpendicular to which is perpendicular to both the vectors, which is perpendicular to both the vectors 14 I cap minus j cap plus 3 k cap and minus 2 I cap plus j cap minus 2 k cap. Please write. Find a vector of magnitude 9 units, which is perpendicular to both the vectors 14 I cap minus j cap plus 3 k cap and minus 2 I cap plus j cap minus 2 k cap. So when you see this word, a vector perpendicular to both the vectors, what idea comes to your mind? Cross product. Perpendicular to both the vectors is cross product. See how to take the cross product of these two. We name these by vector A and vector B, and you are going to find out vector A cross vector B. Then you will convert it into unit vector. How do you convert into unit vector? That cross product by its magnitude. What is the magnitude of a unit vector? 1. Then we have to get the magnitude 9. 9 into 1 is 9. So multiply that unit vector with the 9. We get 9 times 1 as 9. The magnitude of that vector will be 9. So because of this word, I repeat, because of this word, which word? Perpendicular to both the vectors, we have to find out the cross product. Because of this, we should find out the cross product. So let's start. Let vector A is equal to, let vector A is equal to 14 I cap minus j cap plus 3k cap, and vector B is equal to minus 2I cap plus j cap minus 2k cap. So we took these two. Now we are going to find out the cross product. That cross product will be the vector which is perpendicular to vector A and vector B. The vector which is perpendicular to vector A and vector B, both vector A and vector B is equal to vector A cross vector B. It is vector A cross vector B. The vector which is perpendicular to both vector A and vector B is vector A cross vector B. Vector A cross vector B. The vector which is perpendicular to vector A and vector B is vector A cross vector B. Now we are going to find out the cross product. Cross product is determinant I cap, j cap, k cap. Then we get 14 minus 1, 3, minus 2, 1, minus 2. Like this, we write the determinant form. I cap, j cap, k cap. 14 minus 1, 3, minus 2, 1, minus 2. Yes. Can you open this determinant and simplify? So here we get the cross product by this calculation. We are going to get the cross product. Yes, everybody please try to open this cross product. Yes, Lynn, so you got the answer like this now. I cap into 2 minus 3, 2 minus 3, minus j cap into minus 28 minus minus 6 plus 6 plus k cap into 14 minus 2. That is minus I cap minus 28 plus 6. What about minus 28 plus 6? Minus 22. Minus 22 into minus j cap is plus 22 j cap plus 12 k cap plus 12 k cap. This is vector A cross vector B. Clear? This is vector A cross vector B. And then we find magnitude of vector A cross vector B. Magnitude of vector A cross vector B is equal to root of, what do you get, children? Minus 1 square plus 22 square plus 12 square. Root of 1 plus, now 22 square is 22 times 22. What is 22 times 22? Or 484. plus 144. 484 plus 144. So when you add these three, what do you get? 629. So every question of this type, you will find out the cross product. You are getting the vector which is perpendicular to both. After that, we are getting the unit vector and then multiply that unit vector with a 9. Okay, so done till here. Yes. So now the next step is unit vector perpendicular to unit vector perpendicular to vector A and vector B is equal to vector A cross vector B by magnitude of vector A cross vector B. That is minus I cap plus 22j cap plus 12k cap by root of 629. Root of 629. This is the unit vector perpendicular to vector A and vector B. Unit vector perpendicular to vector A and vector B. What is the last step? Multiply this with a 9. So, vector of magnitude 9. Vector of magnitude 9, which is perpendicular to vector A and vector B. Which is perpendicular to vector A and vector B is 9 times that above unit vector. That is 9 times minus I cap plus 22j cap plus 12k cap by root of 629. Okay, so you leave the answer like this. This is the complete answer to this question. Oh, we can. So we can open the bracket and split, but if you keep like this also, you will get full mark. Okay. So is it clear? That concept is clear. A vector perpendicular to means you will find out the cross product. Unit vector perpendicular to means you will find out the cross product by its magnitude. Then a vector of magnitude 9 units, which is perpendicular to means 9 times that unit vector. 9 times is unit vector. Okay. Next, we have one more question in vectors. So that is a question based on direction ratios and direction cosines. All of you remember direction ratios and direction cosines. When we start 3D geometry, the first exercise is also based on that. Again, direction ratios and direction cosines. So in direction ratios and direction cosines, we studied alpha, beta, gamma, 3 angles. In the introductory part, we studied. What do we call these 3 angles? Direction angles. Alpha with which axis? X-axis. Beta with the Y-axis. Gamma with the Z-axis. Right? The 3 angles we take. Cosine of these 3 angles. Cosine of these 3 means cos alpha, cos beta, cos gamma are called direction cosines. Right? LMN. What's the relation connecting LMN? L square plus M square plus N square is equal to connecting LMN. L square plus M square plus N square is equal to 1. And then we have studied a component form. In component form, when you write a position vector, vector OP as AI cap plus BJ cap plus CK cap, the coefficient of I cap, J cap, K cap are the direction ratios. All these are there in the notebook. Okay, you have to study it well if you have not revised it and do the DPP. And then how do you get a direction cosine from that type of vector? Do you remember? If a vector is given AI cap plus BJ cap plus CK cap, how do you get direction cosine? Convert it into unit vector, right? Vector A by magnitude of vector A vector by magnitude of A vector. Then that A cap you get coefficients of I cap, J cap, K cap in this unit vector are called the direction cosines. Is it? LMN. That means if you write Li plus Mj plus Nk, it is a unit vector. It is a unit vector. All these are there in the notebook. Okay, so please revise again and again until you get that concept clear. Okay. So now based on that one, we have a question in vectors. Please write. If a unit vector, right, if a unit vector vector A makes angles pi by 3 with I cap, pi by 4 with j cap, and an acute angle theta with k cap. Then find vector A. Find vector A. So read that question. If a unit vector means its coefficients will be direction, cosines. Unit vector coefficients are direction, cosine. Study again. Normal vectors coefficients are direction ratios. Unit vector, their coefficients are direction, cosines. That makes pi by 3 with I cap. I cap is in which direction? Which axis direction? X-axis. What is the angle with x-axis? Alpha, beta, or gamma? So alpha is pi by 3. Alpha is equal to pi by 3. Then pi by 4 with the j cap. What is that? Beta is pi by 4. Gamma is equal to theta. These are the three direction angles. We have to find out this gamma or theta. Then I am going to write out the direction cosines or the relation connecting direction cosines. What is the relation connecting direction cosines? All of you know. Cos square alpha plus cos square beta plus cos square gamma is equal to 1, or L square plus m square plus n square is equal to 1, which means cos square alpha plus cos square beta plus cos square gamma is equal to 1. That is cos square pi by 3 plus cos square pi by 4 plus cos square theta is equal to 1. What is cos pi by 3? Cos 60. Cos 60 is 1 by 2. So 1 by 2 square plus 1 by root 2 square plus cos square theta is equal to 1. 1 by 2 square plus 1 by root 2 square plus cos square theta is equal to 1. 1 by 2 square is how much? 1 by 4. So 1 by 4 plus 1 by 2 plus cos square theta is equal to 1. 1 by 4 plus 1 by 2 plus cos square theta is equal to 1. Okay. What is 1 by 4 plus 1 by 2? Yes. So 3 by 4 plus cos square theta is equal to 1, or cos square theta is equal to 1 minus 3 by 4. 1 minus 3 by 4. What is 1 minus 3 by 4?
1 by 4.
Minus 3 by 4, 1 by 4. Cos theta is equal to root of 1 by 4. Cos theta is equal to root of 1 by 4. So since this theta is what type of angle? acute angle. Acute angle means we take positive square root, 1 by 2. Theta is acute angle. So theta will be cos inverse 1 by 2. What is cos inverse 1 by 2? Pi by 3. 60 degree, pi by 3. Is it clear? Yes. Now, one more step is there. Find out the unit vectoring. How do you write unit vectoring? What are the coefficients of unit vector? Direction, cosines. So you will find out the direction, cosines. What are direction cosines? LMN. What are LMN? Cos alpha, cos beta, and cos gamma. We got all the angles, right? Find LMN. Then we just write Li cap plus Mj cap plus Nk cap. That will be our vector A, because vector A is what type of vector? Unit vector. So please write, children, direction cosines. Direction cosines. L is equal to cos alpha. That is equal to cos pi by 3. And what is cos pi by 3? Cos 60. Cos 60 is 1 by 2. M is equal to cos beta is cos pi by 4. Cos pi by 4 is 1 by root 2. And N is equal to cos gamma. Cos gamma is cos pi by 3. Again 1 by 2. Therefore, vector A is equal to Li cap plus Mj cap plus Nk cap. That is equal to 1 by 2 I cap plus 1 by root 2 j cap. Just a second. Okay, continue to learn. Li cap plus Mj cap plus Nk cap. And please find out the one, Li cap plus Mj cap plus Nk cap. And what will be your answer? 1 by 2 I cap plus 1 by root 2 j cap plus 1 by 2 k cap. This is the answer. 1 by 2 I cap plus 1 by root 2 j cap plus 1 by 2 k cap is the answer. Is it clear? All of you got it clear? Any doubt? So here ends vector algebra. Vector algebra, there wasn't any deletion. It was a lengthy chapter, but the segments you have to practice well. First of all, we studied an introduction of vectors. In that one, we studied unit vectors, section formula, direction cosines, direction ratios, and all. Second part was, what was the second part of vector algebra? Scalar product or dot product. Third part is vector product or cross product. And the last conclusion is mixed sums. Okay, that also we have done. And study all these sums very well and do the daily practice problems. Important applications are their area of triangle, area of parallelogram, area of rhombus, okay, triangle of extradition. All these we discussed. 3D geometry is comparatively small chapter. Actually, in the textbook, 3D geometry content is small, but more than half of the content is deleted from CBSE. Planes, the major part of 3D geometry is deleted. Planes, only lines we have. 3D geometry 11.3 exercise is fully deleted, 11.1 and 11.2, and some selected miscellaneous questions. Main topic of 3D geometry is shortest distance between lines. Already I have given you a video based on that one, shortest distance, and in the class we will do detail, okay? So that is a main part of 3D geometry. 3D geometry first part is continuation of vector algebra. Some questions based on direction cosines and direction ratios. All of you know direction cosines and direction ratios, right? Yes, based on that one, we have some questions. So we will directly start the 11.1 exercise of 3D geometry. Then the clear basics of vector algebra is required to study 3D geometry. So if any part from vector, if it is pending, that also you have to revise and study well. Okay, so now write the subheading, chapter heading, three-dimensional geometry. Chapter heading, three-dimensional geometry. Chapter 11, three-dimensional geometry. Please write chapter 11. Three-dimensional geometry. Or 3D geometry. First part of this chapter is questions based on direction, cosines, and direction ratios. All of you know alpha, beta, gamma, three direction angles. Cosine of these angles, cos alpha, cos beta, and cos gamma are called the direction cosines, cosine values, and then the proportional numbers are direction ratios. LR, MR, NR, which are proportional, are called direction ratios. Write a question. If a line makes angles, this is from 11.1 introductory part question. If a line makes angles 90 degree, 60 degree, and 30 degree with positive directions of xy and z axis, then find the direction cosines. Find the direction cosines. Okay. So here we take the three angles as alpha, beta, and gamma, because the direction angles with x, y, and z axis means what are these three angles? Alpha, beta, and gamma. So right, alpha is equal to 90 degree, beta is equal to 60 degree, and gamma is equal to 30 degree. Now L is equal to cos alpha. That is cos 90 degree. What is cos 90 degree? Yes, 0. M is equal to cos beta. That is cos 60 degree. What is cos 60 degree? Yes, 1 by 2. And N is equal to cos gamma, which is cos 30 degree. Cos 30 degree is root 3 by 2. Cos 30 degree is root 3 by 2. Now we can write LMN, the direction cosines. LMN is equal to 0, 1 by 2 root 3 by 2. 0, 1 by 2 root 3 by 2. Okay, LMN or 0, 1 by 2 root 3 by 2. 0, 1 by 2 root 3 by 2. Is it clear? Yes. Similar type of one more question. It is also from 11.1. If a line makes angles, if a line makes angles 90 degree, 135 degree and 45 degree with X, Y and the Z axis respectively. Then find its direction cosines. Find its direction cosines. Right. If a line makes angles 90 degree, 135 degree and 45 degree with the X, Y and the Z axis respectively, then find its direction cosines. Here also the same way, alpha, beta, gamma are given. Right, children, alpha is equal to 90 degree, beta is 135 degree, and gamma is equal to 45 degree. Gamma is equal to 45 degree. Then L is equal to cos alpha, which is cos 90 degree. What is cos 90? Cos 90 is a 0. M is equal to cos beta, that is cos 135 degree. How do you write cos 135 degree? 180 minus 45. It is in which quadrant? Second quadrant. Second quadrant, the cos is negative. So minus cos 45 degree, that is minus 1 by root 2. Second quadrant, the cos is negative. Is it clear? Cos 135, 180 minus 45. Then n is equal to cos gamma. Cos gamma is cos 45 degree. Cos 45 degree is 1 by root 2. Therefore, the direction cosines LMN are cos alpha, cos beta, cos gamma, which is 0, minus 1 by root 2 and 1 by root 2. 0, minus 1 by root 2 and 1 by root 2 are the direction cosines. Clear? 0, minus 1 by root 2, 1 by root 2 are the direction cosines. Yes, all of you understood this. Next. Find the direction cosines of a line. Find the direction cosines of a line. Find the direction cosines of a line. What happens? Okay. Which makes equal angles. Which makes equal angles. Equal angles with the coordinate axis. With the coordinate axis, which makes equal angles with the coordinate axis. This is an important MCQ type question. Equal angles means alpha, beta, gamma are equal. Then how do you find what relation to be applied to find out alpha, beta, gamma? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, so right. Here alpha is equal to beta is equal to gamma. Here alpha is equal to beta is equal to gamma. Here alpha is equal to beta is equal to gamma. Okay, so now we apply the condition cos square alpha plus cos square beta plus cos square gamma is equal to 1. The relation connecting direction cosines, which means cos square alpha plus cos square alpha plus cos square alpha is equal to 1, or 3 cos square alpha is equal to 1. What is cos square alpha is equal to 1 by 3. Cos square alpha is equal to 1 by 3, which means cos alpha is equal to root of 1 by 3. What is root of 1 by 3? Plus or minus 1 by root 3. Here we take plus or minus because direction cosines can be positive or negative. In the previous question also you got one of the negative, right? Cos beta we got negative. Okay. So here we take plus or minus. Therefore, find out the direction cosines means all are equal, right? All are equal. Therefore, LMN all are equal here. Therefore, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. Okay. In direction angles alpha, beta, gamma are not only acute angles. They vary from 0 to 180 degree. Okay, 180 means cos values are negative in the second quadrant. So it can be negative values.
So if alpha can be even beta, right? Can be cos square beta plus cos square beta plus cos square beta, right?
Yes, yes.
Okay.
It is the same. This question is an important MCQ or 2-marker type question. Now, if two endpoints are given, you know how to convert into vector. Like ax1, y1, z1, bx2, y2, z2. How do you convert it into a vector? x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Like this, two endpoints of a line may be given and write the direction ratios and direction cosines. What do you have to do? You will convert it into vector. Then the coefficient of that vector will be the direction ratios. Then you convert it into unit vector. Coefficient of unit vector will be the direction cosines. Do you want to do one more question of that type? Only we have discussed in the last chapter. Do you want to write one more question? Yes, right. Please write. That is also MCQ or 2-marker type. Find the direction cosines. Find the direction cosines. Find the direction cosines of the line segment joining the points capital A 3, 5, minus 4, capital A 3, 5, minus 4, and the capital B minus 1, 1, 2, capital B minus 1, 1, 2, capital A 3, 5, minus 4, and capital B minus 1, 1, 2. Okay, find out the direction cosines of the line segment joining the points. So first of all, you will convert this line segment into vector form. Vector AB is equal to that vector form, all of you know, if two endpoints are given, x2 minus x1 into I cap, which means minus 1 minus 3 into I cap plus 1 minus 5 into j cap plus 2 minus minus 4 into k cap. That is equal to minus 4 I cap then minus 4 j cap plus 6 k cap. So this is the vector. Coefficient of this vector will be the direction ratios. If direction ratios are asked, what will be your answer? Minus 4, and 6. If ratio, if it is asked, we can reduce it, okay? Minus 2 is to minus 2 is to 3. That way MCQ's answer will be there. But here what is asked? Direction cosines. You will convert this into unit vector, right? Unit vector in the direction of vector AB. Unit vector in the direction of vector AB is vector AB upon magnitude of vector AB. So don't forget, coefficients of unit vectors, unit vector will be the direction cosines. So this comes like this, minus 4 I cap, minus 4 j cap plus 6 k cap upon square root of minus 4 square plus minus 4 square plus 6 square. That is equal to minus 4 I cap minus 4 j cap plus 6 k cap upon root of 16 plus 16 plus 36. So what do you get here? Root of 68. Root of 68. Root of 68 means how much it is? Root of 68. Yes, 4 into 17 means 2 root 17. 2 root 17, which means minus 4 by 2 root 17 I cap minus 4 by 2 root 17 j cap plus 6 by 2 root 17 k cap. So this is minus 2 by root 17 I cap minus 2 by root 17 j cap plus 3 by root 17 k cap. Okay, and these coefficients are the direction cosines. So the direction cosines are minus 2 by root 17, minus 2 by root 17, comma 3 by root 17. These are the direction cosines. Clear? This is the introductory part of 3D. Now we start the main content of 3D, that is straight lines in 3D space. Last year you studied straight lines in planes. Plane means what is the dimension? 2D. Last year you studied a straight lines, say full chapter, it was there, straight lines, equations of straight lines. 5 different forms you have studied. But that was in 2D. This year we have straight lines in 3D space. Okay, so let's start. Straight lines in 3D space. Subheading. Straight lines in 3D space. There are two equations of straight lines in 3D space. One is a 1-point form. 1 point on the straight line will be given and a parallel vector will be given. And second is 2-point form. 2 points on the straight line are given. In every equation, we write two forms, vector form and the Cartesian form. Vector form is in terms of the position vectors. Cartesian form is in terms of the coordinates, x, y, z. Last year, you studied only Cartesian form. There wasn't any vector form. But this year, every equation, we have vector form and a Cartesian form. So write the subheading, equation of a subheading, equation of a straight line in 3D space. Equation of a straight line in 3D space. Equation of a straight line in 3D space. Number 1, equation of a straight line passing through a point. Equation of a straight line passing through a point and parallel to a given vector. Please write. Equation of a straight line passing through a point and parallel to a given vector. Equation of a straight line passing through a point and parallel to a given vector. So from the heading, you can easily understand two things are given here. Passing through a point on the straight line is given, and what is the second given factor here? Parallel to a given vector. So we'll draw a diagram in that a straight line in space. Space means x, y, and the z axis. So let's draw a diagram. If you have scale and pencil, draw neat rough diagram like this, x, y, and the z axis. Origin O, origin O, origin O, okay, so this is a straight line. A point on the straight line is given. Let's take that point as capital A. Capital A is a point on the straight line. And then a parallel vector will be given. So the parallel vector we mark as vector B. Vector B is a vector which is parallel to this given straight line. It is vector B. These two are given. A point on the straight line is given, a parallel vector is given. Yes, did you complete the diagram till this? Yes, done till here. Now for the vector form, we take position vector of this point A. Position vector, how do you draw? From the origin. So please join from origin to the point, okay? And you will mark this vector as vector A. Position vector of the given point is vector A vector, small vector, A vector. And every equation, we take any point on the straight line. There are infinitely many points on the straight line. Out of the infinitely many points, any point on the straight line should be taken as P, capital P. Its position vector is vector R. That means you will join OP. OP's position vector is vector R. Vector R. Now using these, we are going to write the vector equation using position vectors. Okay, so let's write first one, vector form, vector form. Vector form. From figure, vector AP is parallel to vector B. All of you know when two vectors are parallel, how do you connect these two by is equal to sign? When two vectors are parallel, one vector will be what multiple of the other? Scalar multiple of the other. So we can write, that means all these concepts, basics are from vectors. Vector AP is equal to, how do you write vector AP? Lambda times vector B, where lambda is a scalar. Where lambda is a scalar. Now, vector AP in terms of position vector. How can we write vector AP in terms of position vector? Position vector of the second point minus position vector of the first point. So tell me, how do you write? vector OP minus vector OA is equal to lambda times vector B is equal to lambda times vector B. Now, vector OP is, what is vector OP? Vector R minus vector A is equal to lambda times vector B, which means vector R is equal to vector A plus lambda times vector B. Vector R is equal to vector A plus lambda times vector B, where vector A is the position vector of the given point. Vector A is the position vector of the given point. Vector B is the parallel vector. And R vector is the position vector of any point in the straight line. Is the position vector of any point in the straight line. So this is all about the first form, vector form. For this one, Cartesian form also there. So that one I will explain next class. So please study the theory part also very well. Okay, understand the theory part with the help of diagram. So explain it accordingly. Okay, and when you see a question, this picture should come to your mind. What is this vector A? What is this vector R? What is this parallel vector? Its position. All these things should be in a frame in your mind, and you have to write it accordingly. Okay, so study the vector form. Vector R is equal to vector A plus lambda times vector B. Thank you all.